Hello everyone, my name is Susie Lemon, and today I'm presenting the article titled Body Size, Breeding Habitat, and Winter Exploitation Systems in Dendroica, and that's basically the warbler species. This paper is done by Russell Greenberg. So this introduction is relatively short compared to the other articles we've been reading, but it's basically saying that he's studying 16 different warbler species that breed in North America. All of these species have very similar body plans, so it's hard to tell them apart. So the main way to do that is by their behavior. We're going to be evaluating relationship between body size, foraging style, habitat selection, and winter exploitation systems. For methods, he's measuring the sternum and wing length of 178 male skeletons, and the way he uses this with the mathematics equals about the total body weight. The behavioral analyses for this paper is mainly done from literature, and the wintering data we got is actually from Greenberg's previous experiments. So this is all the figures and tables in the article. And the one all the way on the left, this one here, is basically telling us that sternum length and bony wing length have a positive relationship, meaning that the bigger the sternum length is, the bigger the bony wing length is. Another good information that he has here is the type of habitat that they breed in. The black triangle, so like this one, is species that breed exclusively in deciduous forests. The white circle, the ones up here, are birds that breed exclusively in boreal forests. The black circle here is birds that breed both in deciduous and boreal forests. So from now on, for simplicity, I'm just going to call them mixed forests. And from this graph, we can interpret that larger birds tend to breed exclusively in boreal habitats. Table 1, which is this middle top one, is deciphering against two different species, which is D. pennsylvanica and D. contania. D. pennsylvanica is a species that breeds exclusively in deciduous forests. D. castanea is a bird that breeds exclusively in boreal forests. So we're evaluating the behavior and foraging, the way that they flock, as well as their spacing behavior. D. pennsylvanica pretty much shows not a lot of variety in the way that he forages, so he's very specialized in the food that he eats. He also is seen mainly in mixed species flocking, and very rarely is he seen in single species flocking. And he has small exclusive home ranges. This tells us that he can exploit microhabitats. D. castanea, on the other end, he's very variable in his foraging styles. So we can interpret that he's like a generalized in the way that he eats and the food that he eats. This species in particular is seen in both single and mixed species flocking, and he has large overlapping home ranges. So he uses a lot, like his radius that he uses is a lot bigger, and this could be interpreted by the way that he forages, which is very opportunistic. As seen in Table 2, these are deciphering between all 16 species, and it's really interesting because all the species that breed in the boreal forest show some type of opportunistic foraging behavior. In contrast, all the birds that breed exclusively in deciduous and mixed forests don't have any opportunistic behavior. And I would like to add that D. magnolia, the one here, says none, but from this graph he actually breeds exclusively in boreal forests. So he's kind of an oddball in this experiment. Table 3 is deciphering between all 16 species again, but in this case it's on whether or not they do single species flocking. Again, all the boreal species tend to be in single species flocks, but the deciduous and mixed species have either no or a question mark to it, meaning that it's not recorded. As well as D. magnolia, he also isn't seen in single species flocks. This middle bottom one here is basically telling us that two species, one is a large species and one is a small species. On the same amount of fat load, the bigger species is more likely to survive in unpredictable habitats such as cold weather as well as starvation streaks. So from all those graphs put together, we can say that larger species, mainly ones that breed in boreal forests, have larger home ranges, they're more opportunistic in their foraging behavior, and they're more gregarious, meaning social, compared to smaller species, and this includes D. magnolia, even though he breeds exclusively in boreal forests. Large and small species each have their own advantages. The smaller species is more able to exploit microhabitats. They specialize in foliage insects, and that's basically insects that live on leaves, and they have increased maneuverability. And this can be seen by their deciduous habitat. So deciduous forests, they tend to have a lot more branches that kind of come out randomly, and they have broader leaves, and this is easier for a species to exploit if they're smaller, especially because a lot of the branches are very thin in deciduous trees. And because of the broad leaves, a lot more insects are able to fit on there and live on the leaves. So this explains why smaller species tend to specialize on foliage insects because of their environment. Also, they have more increased maneuverability. When you see a deciduous forest, you can see that they're spaced randomly or they're clumped, and in the middle of the canopy there, these branches are spreading in every which way very randomly. So in order to be able to fly through those obstacles, you need to be smaller, hence species that breed in deciduous forests are smaller. There are advantages for large birds as well, and one that we see in this paper is that they're more opportunistic in both environments, and by that I mean breeding habitats and wintering habitats. They're more specialized at locating food in general. They have a lower metabolism and tend to be more dominant. The reason why they're opportunistic is mainly because of their breeding habitat, which is the boreal forest. These forests are unpredictable. They can be cold, and in return, that can make different foods not as abundant as other times. And if these birds were to specialize on one type of food and it died out, they need to start eating different kinds of food in order to survive in these boreal forests. And since they're opportunistic in the boreal forest, when they fly south for wintering, they're in deciduous forests and they just keep their opportunistic behavior because they're not adapted to that deciduous forests. They're more specialized at locating food, and again, this goes with different food abundances during different times. And this can mean that they do eat foliage insects, but they're also able to eat insects from the air and catch them in the air. And not only that, they can also switch to seeds and fruits. And so they need to be able to know how to find these seeds and fruits. They tend to have a lower metabolism, so this is more able to conserve energy, and in case of a starvation streak, they're much more likely to survive if they're large. And when it's very cold out, larger bodies tend to lose heat less often than smaller species, as well as since they're bigger, they get more insulation. And larger species tend to be more dominant. This isn't a set in stone idea, but this could have been the initial driving force for why larger birds began to evolve, because they wanted to be bigger so they could have more access to nesting sites as well as access to food. So the main causes for the large birds' evolvement, though, is from the cold weather and the starvation streaks, which is much more common in boreal forests compared to deciduous forests. The very first warbler species lived in deciduous forests, which explains why smaller species tend to be much more specialized for their environment. And these boreal bird species are a much more derived trait than breeding in deciduous forests. And due to this, scientists have come up with two different models for where these ancestors came from. The first one is ancestors came from mixed forests, and they had characteristics that were pre-adapted to boreal forests, even though they didn't live exclusively in those forests yet. Unfortunately for this theory, the only way for it to make sense is for there to be a lot of extinctions. The second theory is that ancestors from less seasonal coniferous forests evolved with the forest when they became more seasonal. And this was due to climatic cooling. Before the ice ages, the earth in general was relatively more warm than it is today and between the ice ages. So when the ice ages came, the forests had to evolve, and since the forests evolved, the birds had to evolve. This theory is much more parsimonious than that first one, so scientists tend to lean more towards this one, especially because there's no hard evidence on either of the theories. So we're going with the second one. For my questions, my first one is, why do you think that D. magnolia evolved to live and breed in the boreal forests when it's a small bird, especially because it behaves as a small bird that lives in deciduous forests? The second question is, do you think this correlation for body size, habitat, and foraging styles is the same with other kinds of birds? And if so, why? The last but not least is, what would you expect would be the body size and foraging style of a bird that lives in a tundra habitat, at least according to the findings of this paper? All right, that's it for me. Thank you guys for listening, and have a great day.